Summer in the hills, those hazy days I do remember. We were running still, had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms, this is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
Good evening, everyone. Okay, something is terribly wrong with my camera. Please bear with me a second. I'm actually going to leave the music on. Okay. Yeah, so... yeah, my white balance was incorrect. Okay, perfect. So I guess we can get going. Good evening, everyone, and welcome to another one of my live streams. And tonight we are going to talk about Arcane Sector again. Last week we already did that, and we talked about, well, the tasks which we had in Arcane Sector Online, the MMORPG game which was prepared for the Dragon CTF, which took place a month ago. Well, not even a month, a couple of weeks ago. And I solved on the previous live stream, well, solved or semi-solved, I think like 6 tasks which were in the game. And today, and probably on the next stream as well, I would like to talk about how the game was created, because it actually took quite a lot of effort to create and to make. So yeah, I wanted to basically, this and probably the next stream, maybe 2 next streams, depending on how long will it actually take, will be more about programming, about designing, and about solving problems in programming than about security. I might talk a little about security as well, because, well, I guess programming and security are kind of interchangeable, so you do have to take security into account when designing stuff and when implementing stuff. So yeah, but the main topic will basically be programming and describing how the game was designed. Today's moderator is Foxtrot Charlie, so if you have any questions, do ping Foxtrot Charlie. His nickname is right here. Yeah. Exactly in this corner. And if you're on IRC, actually, on our IRC channel, you know, IRC freenode.org, then and hash Gunveil streambar, then you can type !Q and then the question, and I will get the question as well. So before we start, actually, some usual stuff, and I know there are some questions as well. I know there are a lot of questions. And then I'm probably going to play some music for about 5 minutes while I push the source codes of the game to GitHub, so you can actually, you know, see what I'm talking about and compile it, like play with it, and yeah, and then we will begin the real topic. Cool. So moving here, oh wait, so there's something seriously wrong with my, yes. No, here's the problem. Actually, my keyboard shortcuts do not work, and I cannot zoom in. And this is really bad because I need to be able to zoom in. Let me run Logitech. Actually, my keyboard is kind of failing. I have a Logitech keyboard, and usually it has like 2 rows of additional function keys. It's like from G1 to G12, and I usually have, like, you know, zooming the screen and writing on the screen, so I'm bound on these keys. However, if there are no drivers, I cannot really do anything like that. And yeah. So we start with technical problems. That's typical. Okay. Thankfully, it is a common problem, and actually. Yeah. Okay. Now it works. It is a common problem, and I already have written scripts to fix it, and it works. Perfect. So, this is Foxtrot's website, foxtrotlabs.cc, and let's see. No, I actually know he didn't publish anything yet. He said he will have a new blog post ready for tomorrow. So let's like keep our fingers crossed. Do check out his website though, and again, thank you, Foxtrot, for helping me with the live streams. Then the other shout out I wanted to give is to this DevNull channel on YouTube. Yeah, so this is Zanit, and yeah, here, and he actually has. Oh, the stream looks blocky. Sorry. Okay, I will get to the remark later. Anyway, so yeah, this is Zanit's channel. He basically does both live streaming and videos on security. So if you are missing some more security content or CTF content for that matter, do check out his channel. You can find it by looking for like DevNull on YouTube, /dev/null, or you can actually, I guess, go to my channel, and I think in my subscribed channels, his channel is there, or I am just going to give you a link. Okay, here's one link, and I actually don't know where I have the other channel of it. Yeah, here it is. Perfect. Yeah, so totally check out his channel, and yeah, I actually met him like last week or this week. Well, yeah. Anyway, a really, really great guy. So totally recommend his content. Perfect. Then yeah, then we go. Okay, there's a remark. Did I decrease the bitrate because my stream looks blocky? Does it look blocky? Maybe I didn't change any settings, if that's the question. It might be blocky due to random reasons. I don't know, sometimes on YouTube it just gets randomly blocky, and then suddenly, like, next week everything is fine. So I'm not really sure it's related to my settings, me not rebooting my PC before the live stream, or something completely different. Okay, let's look at the questions. We met yesterday. Okay, so DevNull says Zanit says we met yesterday. That might be yesterday. Actually, like, my schedule is crazy right now, so yeah, like, I apologize totally for not keeping, you know, what the date is it today. It's more like this meeting, like, you need to go there, this is another meeting, another, and so on, like life of a manager. Cool, questions. You will see the questions down here, and I know there is a whole set of questions from Kili. So, When will Disconnected publish his book? Disconnected is one of the people who are helping me with the live stream, and he's also a CTF player, an expert in security, basically. So it is a just question. Disconnected, when are you going to publish your book? Probably when he writes it. That usually helps to write a book and then publish it. Let's see how it goes. When will Foxtrot Charlie make his stream? Good question as well. When will KrzaQ publish his book? Probably after writing it as well. When will be OSDev stream? Actually, on my Polish live streams, I did have a series about OSDev, and it, ended at the usual place where people stop with OS development, and that's around the keyboard drivers. I'm thinking about getting back to it actually, but probably sometime next year. Especially like if I would, go ahead with my idea of using the same topic on both my Polish live streams and my English live streams, then probably OSDev is going to be one of a series I will restart. Yeah, same with ray tracing. Ray tracing was also another thing I did on my Polish live streams, but kinda it fell apart at one moment. So yeah, might be worth going back to it. When will I publish my new book, not the reprint? No plans for a book at this point, but some other stuff, yeah. What's your rank in CSGO? I'm currently designated Master Guardian, also known as a Sheriff, which is, I think, like somewhere in the 2/3 of it. So not great by any means, but not terrible either. When my questions will be satisfied with you making OSDev? Yeah, probably when I make the OSDev. When will you make a live stream with you and the moderators versus viewers in a CSGO match? That is an excellent idea, actually. I just need to get my moderators to start playing CSGO. Yeah, actually. But that would be a fun idea. I wouldn't mind, but I do... My language when I play Counter-Strike isn't the greatest, so I probably should have my microphone turned off. When will you make a review of the hebi OS? Actually, I know one person who contributed to that project. I might be able to get them to a live stream. I need to check, but that's actually a cool idea about the hebi OS. hebi is it's an open source reimplementation of BIOS. If you never heard about BIOS, then like not BIOS, but BEOS. Then I don't blame you. I actually I never used it either. But there was such a thing in the past, and then hebi is one of the reimplementations of it. I think there was also OpenBIOS. I might be mistaken though. Yeah, that's actually an excellent idea. It looked really fun. Okay, and when will you make OS review series? Depending on... That's actually a good question. What do you mean by OS review? Do you want me to, say, oh, the design of the new menu is not great because I don't like the colors, or do you want me to look into the kernel or something? If we run out of topic, that might be feasible. Can you stop ignoring questions you don't want? Let's skip this question. What should I write about memoir of admin in NGO or security challenges in NGO, or maybe short story about how I learned to code? You have a lot of questions, Kitty, today, like more than usual. Actually, the first one, memoirs of an admin in NGO, that would be fun to read. Like, case studies are usually fun to read, or fun to watch presented. Why does Microsoft has recently so many problems in Windows 10 instability? So a theory or a hypothesis I've heard about that is that they actually cut down the testing department. Like, they had some quality assurance folks and now it's minimized. I'm not sure how much truth is it in that, but that's what I've heard. So it's, spreading gossips, basically. If that would be true, then it might explain it, because, yeah, like, all the recent big patches had some issues with them. Did I decrease the bitrate? Yeah, I already talked about it. I didn't. And actually, like, yeah, it looks like the frame rate on YouTube isn't the greatest today. Sorry about that. What do you think of new defenses against binary exploitation such as shadow stacks and pointer authentication? Do you think binary exploitation will be much harder because of them? It's a good question. I didn't look at the attacks on these mitigations yet. Shadow stack, yeah, I mean, on paper they look really cool. Whether they will kill the bugs, I doubt that. But yeah, if I have some time, I'm totally going to check it out because yeah, I guess the real reason I didn't look at them yet is that they are not common on CTFs yet. Like a control flow guard was on CTF though, so. What do you think about external anti-exploit mitigations provided by some AV programs? I didn't review them. I have no idea what these are doing. I've read one review of one such thing sometime in the past and it wasn't helping at all. So actually no idea. But it is an excellent question again, and reviewing that piece of software sounds pretty important, especially that security vendors have a bad history of security in their products. So I would take a look if you have some time, right? Christmas stream in CSGO. I mean, we might think about it. Any suggestions about cryptography books? So it's like this. I am not an expert in cryptography by any means. What I've heard was recommended, or what I have on my bookshelf right behind me is Bruce Schneier. I think I have most of his books. Some of them signed actually. Then JP Aumasson, who had this, how was it called? Serious Cryptography, which was published last year with No Starch Press. I really enjoyed that book, and I didn't read it cover to cover yet, but I really like every page. I learned something new, so I really like it. It has a more practical hands-on approach, but I like it probably because I already know something about cryptography, and then he adds the details I'm missing, I didn't know about. So that's pretty cool. And then there is this, I think, Coursera course about Cryptography 1 or Cryptography 101, something like that, and that's really recommended a course to take, so you might want to start with that. Do ask cryptography experts about that, like how to start with cryptography, because again, I am not a cryptography expert, so yeah, I know some cryptography, enough applied cryptography to like, you know, do my job and play CTFs, but that's about it. Like in comparison to real cryptographers, I just don't know stuff. By OS review, I meant reviewing families of operating systems like Linux, BSD, or less known like Plan 9, ideas behind them, and so on. It is an excellent idea. I would have to learn that stuff myself, like by heart first, because for me, like Linux, BSD, kind of the same thing. Like I know that the philosophy differs a little, but that's the end of my knowledge. So yeah, I'm probably not the best person to do it. Any good papers about these mitigations? Why they are not in ciekawe papierki? Probably yes, but do look in this mailing group. There might be some papers about them. Otherwise, just Google it. Sorry. Is there any chance to do your ASM tutorials in English? Basically, I'm planning to record a full series of ASM and reverse engineering tutorials of assembler and reverse engineering for 64-bit Intel. But that will be probably premium content, mint paid content. So yeah, so there's that. Like, yes, it will be there in the future, but probably not as free videos on my YouTube channel. Sorry. Okay, that's the end of questions. So I'm going to play some music, and I'm going to push the code to GitHub so you can take a look, and then we will start going through the code. Cool. So okay, like you might want to, you know, decrease the volume. I'm not really sure what's the volume for the music. So okay, but be right back in, I guess, like 2 minutes. Okay, so I'm committing it. It's on my. It will be on my GitHub. Let's see how long it takes to push actually, because that's several megabytes. Rejected. What contains work that you what? Git pull. Okay, now it's pushing. Okay, so if you want to, let's start with this. If you want to get the source code, you need to go to my GitHub, and I totally recommend you to do it. So my GitHub is github.com/ginvale, I mean no magic there, and repositories, and then Arcane Sector. Yeah, and now, yeah, it's already committed. So here it is. You might want to check out the passwords. That's all the account passwords for, like all the passwords for the default 256 accounts. You might need them. And you actually can log in using these credentials to this address and the default port of the game. The default port is 5001. So if you are able to compile the client, there's actually a backup file, the backup.zip file, which contains the Windows version of the client, I believe, and also a thin client Linux version. So if you are able to run it, then do connect to this IP, this port, and then do use the default, one of the default passwords, like select, I don't know, player22, and this would be the password for the player22. There is no more the thin client web interface running, because that requires basically 1 gigabyte of memory to, for each client, and if like 20 clients could connect, that would kill the server, and I'm pretty sure there are more people than 20 on my live stream right now. Yeah, there's like 130. So actually if you want to check it out like live, then do connect to it. I guess I can run a client as well, just to see where. How do I connect variable? So yeah, just to be sure, this is how you do it. Like select an account, put the password here, get the IP, again 35, 234, 67, 100. You can set up the server yourself locally, so it's just there for your enjoyment basically. And then, yeah, that's not HTTP though. And then we need the client ID. These are all test accounts, so yeah. Okay. And now let me run it. So, oh wait, I need to actually make the console bigger for today. Okay. And okay. Yeah. So, I saved it. And yeah, I learned that like in Sublime, if this is a circle, then it's not safe. If this is an X, it is actually saved. So yeah, so I connected and I'm in the game. If you connect, I'm actually going to take a step back to see if anyone of you is able to connect. Remember, if you press enter in the game, there's a chat. Cool. So now we can chat about how the game is actually made. If anyone connects to this, I get log out. So yeah, if you want to log me out, then basically connect to the same account. Okay, so let's, I guess, start with how the, like, what's the directory structure there on the, so I guess we can use GitHub actually to show the account, the stuff, right? And if you're, by the way, if you're planning to run your own server, do not use the default passwords, obviously, right? This is, yeah, again, obvious. So, yeah, let's start with the directories. Now, the client is the actual client of the game, so it's this, right, which you see here. Then the server is obviously the server. The tests, if you're thinking the tests contains tests for everything, then you are seriously mistaken. It contains only one test of like one part of a CTF challenge, so there's only one file there, you can totally ignore it. Then there's the thin client. The thin client was the the thing. It was basically an HTTP server. I guess we can talk about it later, but it's an HTTP server and a website. So if you enter the website through the backend, you span a real game client and you can play through a website, right? You can play this game using just a browser. So this is the thin client, which enables you to. It doesn't really enable you to do it because it's part of the client code to enable you to do it, but it's something which proxies the WebSockets. Then screens contains the screenshots. I can show you them in a second. Passwords contains the default passwords. Attic, as the name implies, contains everything which is world related. Yeah, I know. So originally I just put like temporary files in the Attic. That's usually how I name my files, name my directories where I put files which might be needed later and I don't really want to delete but are no longer part of a project. So, an attic in a house is the thing you have under the roof, right? To store all stuff. And it's supposed to be that, but in my case, actually, I started putting like the world map, the sources of the world basically there. And yeah, in the end, I didn't want really to rename the directory because my paths would mismatch. So yeah, so that's how it's stayed in Attic, which is hilarious. I probably need to rename it later on. And yeah, that's basically it. Makefile doesn't do what you think it does. The backup here is actually the thing which contains the compiled version of the Windows client. And also the server, but yeah. Okay, so yeah, I guess nobody connected yet. Cool. Now the README file actually in this repository is pretty long, and it contains stuff like the protocol and so on. So yeah, this is the main directory structure, and I'm going today and on my next live streams, I'm actually going to go through all of these to let you know what were my design decisions and so on. I think we are going to start the way I actually implemented it, and on sorry. On Twitter, somebody asked me like, how long did it take me to design the game? And yeah, I actually didn't design the game. I just designed as I went, as I implemented it. So I didn't have a plan how to do it. I just like started implementing it. I have some experience in writing code already, so it actually is easier if you're new to game development. You probably might want to actually put more effort in designing at the beginning. I kinda knew what I was doing through most of the time anyway, so yeah. So that's why it somewhat worked out. The first thing I actually started with, what I knew about the game that I wanted to achieve. I wanted it to be a multiplayer RPG game in this old style where you actually don't move, like in an FPS game, in a modern shooter game, but you can only move on tiles. So you can rotate only 90 degrees, right? Like this, you can, I guess, see this here. And you can only move one tile to the front or a tile to the back. You can actually move sideways as well, but the idea is that you are moving on tiles, which is pretty obvious if you look actually on the minimap. It's pretty obvious that these are tiles. So these are actually, this is basically a bitmap. The world is a bitmap and each pixel is one tile. One tile is supposed to be, initially I wanted one tile to be 10 meters by 10 meters. So I wanted the world to be like pretty huge. Like in the end, I actually switched to 5 meters by 5 meters. So and each tile is like 5 meters, right? 25 meters square. The reason this is important is because when I wanted to do the 3D engine, then because the 3D engine here is full software written from scratch, right? So and I needed to know my like 1 in this direction, right? Like 1 in the y-axis. What does it mean? It's 1 of what? And I wanted to be 1 meter, and therefore it was important for me to decide on the unit early on, and my unit was basically meters. So that was an initial decision I made, and I wanted it to be like this. I wanted there to be one server, and I already knew that I wanted one server per team because, again, the game was made for CTF, so I wanted each team to have their own server, so one team would not spoil a CTF task to another team. Like, you know, you could be solving your task, right? And another team would be just standing nearby and watching you solve the task, and you didn't want them to do it. Or you could be walking through the maze and another team would just follow you. So I wanted each team to have their own server, and also there to be a common server for everyone who just, you know, joins the CTF to play the game, because every participant of a conference the game was on could actually do that, could actually start playing the CTF. So there would be like each team had a server, the servers would be identical, and then there would be the identical common server. Then the clients would connect, and well, the common way is actually, you know, to have some login and password, right? To be able to authenticate, but this means also you have to create a registering system, so you can register, create new account, and create a player. And I actually wanted to avoid that because that's additional code which isn't really important. So in the end I decided to go for like a client ID, which is a number from like 0 to 255, and a password. And actually the password was common for all accounts, because in the model where each team has their own server, it doesn't really matter how many accounts they have. They can have like 250 accounts for all I care, right? So initially like every account had just one password. Like there was a master password which you connected with to the server, and then you said I want to be client number 5, and it would connect you to the oh, hello. There's 0, cool. Okay, so actually this is the default nickname because for some reason the game doesn't allow you to create an account. We can actually chat. Hi there. You can type enter to chat. We can talk about chatting later because it's implemented in a funny way. Now, okay, Matrix here. Perfect. Hello there. Now, okay, going back to this design, there are a couple of questions, right? Because this is an MMORPG game, and the main question is, okay, so what do you write the client and what do you write the server, and then how do you want to actually synchronize the world for the clients? And there are several ways to do it. Now, I think the best way to do it, at least in my case, was to have only one thread. By the way, the client is in C++, the server is in Python too. I should have went for Python 3. That was my mistake. I should have went for Python 3 due to reasons, but whatever. Yeah. So anyway. So yeah, the way I did it in the end is like this. There is only one thread on the server, like one thread, which is running. This is one thread, which processes all events which you get from the players. So that way, when an event comes, it gets into one common queue. There's no possible way to do a race condition between threads. So yeah, so that was my design decision. Only one thread which does everything. Now, I also knew from the beginning that I will probably need to actually cut this thread into pieces, fibers, because if something requires some time, like, I have a ring of teleportation, and then to bind it, I want to actually sleep 1 second, put out a funny text related to, like, checking the state of the force and so on, and the magic in the background, and then, like, wait 1 second, put out another text, wait 1 second, put out another text, and do something else. If there's only one thread, and if you sleep in that thread for 1 second, you freeze everything. Nobody else is able to move in the world, and so on. So in the end, I decided that I'm actually, like, the processing of the events will not be done in the same fiber. There will be multiple fibers handling that. Which actually means that when a thread starts processing an event, like actually, using a teleportation ring, and then it gets to a sleep, then it would just stop here and go back to the main loop to process the next event. And then when you run out of events, you check, is there any fiber I need to switch to? And then you actually take off from that sleeping fiber, you wake it up and you continue execution. I'm going to talk more about the design of that later on, but that's basically the idea. Obviously, you can raise condition between fibers, and it's somewhat expected. There is not really anything I can do about that. Obviously, stuff like mutexes doesn't really work here, and there is no locking implemented of any kind. So this is a subject to change if you want to do something more with the server, basically. I guess we got some items from someone, Matrix, I guess. Anyway, so yeah, that was another design decision which I made before jumping into coding stuff. Oh, hello there, another person. Yeah, I don't remember. There's basically a bug, but you are able to enter your own name, but if you do not enter your own name in some environment variable, then it defaults to zero cool. Zero cool is basically, you know, the character name from the Hackers movie. Now, having made these decisions, I started with quite laggy. Yeah, it is laggy. That's true. It actually depends. It's not super laggy for me. It might be laggy for you if you are connecting from outside of Europe, I think. Then it will be laggy. Anyway, I started creating the protocol, the network protocol. It's a kind of a funny thing to start from the network protocol, but yeah, that's basically what I decided to do. I decided to note down the network protocol and then implement it in C++, implement it in Python, so you know the server and the client can chat with each other from the get-go, and then build on top of that. That was my idea. Now, test. Yeah, it works. By the way, if you move far away with your character and I barely can see you, then if you type something to me, if you say something to me, half of the letters will be dots. And all of the capital letters would be changed to lowercase letters. A feature of chatting. Okay, so going back to this. Yeah, I decided to make it a binary protocol. I was kind of playing with an idea of making this a JSON-based protocol or making it a Google protobuf-based protocol, which Google protobufs are actually amazing and they would help with a lot of stuff here. But in the end, I decided just to go for a simple binary protocol just to make it easier for the players because, well, Google protobuf is a little harder to manually manipulate, and I expected the players during the CTF to actually manipulate with the protocol. Now, that's one thing. On the other hand, using JSON with C++ is a pain. Like, using it in Python is awesome. It's amazing. It's basically, apart from like tuples and some objects, it's really compatible with Python. It's absolutely not compatible with CPP, and you have to use wrapper functions, and that's a pain. So yeah, so I decided against JSON. I decided just to do a binary protocol. Okay, there are some good questions. Why not call the C++ functions for networking from Python? And this is an excellent question. Now, the reason is because it's like two separate networking stacks. One is for the server, where packets which only the server sends, and packets which only the server receives. And same for the client. So, and these are two different groups of packets. So I had to basically implement sending of this group of packets on the client, but receiving this group of packets on the server. And so there is no overlap in the code actually, or the overlap is minimal. Therefore, I actually had to have two different implementations of two different groups so they don't overlap. Therefore, I didn't go for calling the C++ code from Python. Otherwise, it is actually a really good idea. So yeah, thank you for suggesting that. Cool. Yeah, that was a question by the way from Derbe Survisor, if you're wondering. Okay, so the common part of a packet is basically like this. Well, there is no magic here. It's like a totally basic and standard binary packet design. You start with the size. You can, yeah, this is like super common. Size and the chunk ID. Not necessarily in this order, but usually if you're trying to make a packet-based protocol on a stream transportation system, TCP is not packet-based. That means you are getting bytes of data, but you are not getting packets of data. And what I needed packets. So I needed to know the packet starts here and ends here. This is what I needed to know. And to do that, you actually have to declare the size of a packet. And the first thing the receiver actually does is get the size and then read the rest of the packet. This is basic design of packets like that on TCP. So it's really common. And then usually you have a packet identifier or chunk identifier. This tells the system, like the receiver, what kind of a packet is this, and thanks to this field, you can route it somewhere. I actually went for capital letters here, ASCII capital letters, so it's readable. It's similar like to PNG. Actually, if you've seen PNG format, then this is super similar. And then there's a packet ID. This is a number. In case, so for the most of the stuff which is going on here, the client basically sends requests, and the server updates the state if possible, and then tells the client, here is the new inventory state, here is the new position, and so on. So most of the packets aren't really replies to a packet. It's only like the client sends one packet, and that's it, right? There is no response. But there are a couple of cases where the server actually sends a packet to the client, for example, please select an item. And then the client will select an item or actually cancel an action and not select the item. And then the packet ID comes useful because the packet ID will be the same for the please select an item request, and this item is what I have selected response. And having the same packet ID, I could actually have low on the stack on the server a proper mechanism to wake up a proper fiber depending on the packet ID. So a fiber would request something and wait for an answer, and then when the answer comes, the fiber gets woken up, and yeah, here is your packet with the answer, just parse it and do whatever. So this is why the packet ID is here, and it's supposed to be a unique, per client unique number, 64-bit number, which it's quite easy to generate them uniquely. You just grab a number and increment it by 1 each time, and it's guaranteed to be unique for the probably rest of our lives, right? Why haven't I used coroutines in client networking? I don't think it was needed, actually. I will talk about the client design in a sec, because the client design is also pretty specific. Now, Now, apart from the header of a packet, then there was like each packet had their own, it was basically a separate structure, right? So for example, if I wanted to start the game, this is the first packet which is sent. This is the name of the packet, like a common name, a name for a human. This is the direction. It's sent only from the client to the server. So the client has to implement sending it, and the server has to implement receiving it. And this is the chunk ID, 4 capital letters, enter in this case. Yeah, then there's the description, and then there is, these might not be updated, but whatever. The password string basically, and a player ID. You could probably go for some better authentication here, but there's no crypto here, no SSL. Usually you would want to have at least an SSL layer here, because how does the player know that they connect to the proper server, right? But on a CTF, that doesn't matter. That doesn't matter because we were in a LAN environment. Each team had their own server with their own set of passwords and their own IP. And we hope the network was configured in a way where you couldn't really spoof stuff. So it was enough for that environment. Maybe for like an internet real game, I would go with an additional SSL just to check the certificate of the server here. And then like when the client logs in and the server either cuts the connection if the password is not okay, or actually connects the the player and can say no PC, which means there is no player of this ID, right? And you need to create a new one, or otherwise, otherwise here is your character. No, this is the response to character creation. Otherwise it's like ready to play the game, and just game is sent. And this basically switches to the game screen, I think, or something like that. Now let's look at like a couple of more packet examples, and then we will jump to some other code. So for example, if the player would wanted to move, so you press, for example, the up arrow, then the client actually sends a move request. The move has only a direction. Direction is 0, 1, 2, or 3, and it's mapped as forward. I want to move forward. I want to move backward. I want to strafe left or strafe right. I have the camera inverted if you're wondering why I'm showing wrong directions. Sorry. Yeah. Otherwise, if the player would want to turn, and then there's this direction dire, which is pretty much similar. So you could say I want to turn north. And in case the movement is successful, so the server determines that, okay, there is nothing blocking you, you can actually move in the direction you wanted, they will say, the server will send a position packet. The position packet is actually sent in other occasions as well, like for example, you logged in and you do not know, the client doesn't know where the player is standing. So that's when the position packet is being sent to the client as well. Or you use a teleportation ring or a teleportation spell if there would be one in the game. And again, the server has to update the position of a player. And the position is just, two numbers which are 16-bit each. Again, it's a tile-based map, so 2 numbers is enough to have the X coordinate and the Y coordinate. And also the direction in which the player is looking at. In case the player wanted to change the direction of where they are looking, then it's basically a confirmation that it worked. Otherwise, if a player logs in, then the client also needs to know where the player is looking at. Also, it's used, like, for example, if you enter through the door to a building in the game, then this packet is also sent there. So, let's actually grab these. So if we would, let me show you how that actually works, because that's quite funny. Hello there. Oops, I'm totally going in the right direction. Yeah, so it's not lagging for me actually. This is basically what happens is if somebody is too far away for me to hear, then if my character would be actually even further than that, I would not see even that. So yeah, I'm sorry, I'm not really sure what you meant because I was already running away. Okay, so this is actually a wall which has a special type. Well, no, the wall doesn't have a special type, but on the wall there's an item placed which is called a door, and the client detects that it needs to draw a door here. And what happens is, as you can see on the minimap, when I step through the door, I actually am moved to a totally different place on the map. Well, I'm not inside the building, so yeah, and this is basically how when this packet is being sent. Oh, hello there. Yeah, we got an empty flask, so we can make a mana potion. Thank you for the empty flask, and we have a mana potion now. Okay. Perfect. Anyway, so yeah, then if, oh yeah, and this is actually a good example. When the server wants the client to display some text, then the server will send to the client a text, and the text packet actually is a little bit special because it supports coloring in a funny way. So, you can send letters, but if you send a character in one of these range, in this range, then it's treated as colors, as ANSI escape codes basically, but yeah, it's an escape code for colors. If you send this, then it's the default color. Well, this is the new line, and this is a special escape character after which you render runes. So basically, if we switch to the inventory and yeah, like for example, everything here, this is basically a line of text, and it's printed as a line of text because each rune, which is used for spellcasting, is actually like a font in well, it's two letters in a it's a letter in a font of size of 2 letters. So yeah, if I do something like this, these are actually letters being rendered here. I can show you the text rendering engine later on as well. Now, let's just move here. The items are by the way respawning, so if we grab some battles, then yeah, let's just like grab this battle, it will respawn in some time. But if we would be standing here, we would not get we would not see that the item has respawned. We actually have to move. That's a bug I didn't fix. Cool. Now, okay, and there are other like packets. For example, info packet, which contains the basic information about the player state, which is you know, health points, maximum health points, mana, and so on. The inventory, which says yeah, it's actually, the inventory is pretty funny because I didn't want to have like proper inventory. I didn't want to implement proper inventory, so the way I cheated it is there are 8 positions in the inventory of the player. There are 2 hands, left and right. Then there are 8 slots for the inventory, and actually there is another inventory slot, which is funny because if you hold something, it's actually in yet another inventory slot. So yeah, you can actually, you know, move around just holding item and have your inventory full otherwise, and that still would work. So the inventory in this game is pretty weird because, you know, usually in games you have unlimited inventories, or you have a system of backpacks, or you can carry more, and here you can only carry well, effectively 11 items. So yeah, there's the type, a subtype, which is called item, and this pack is basically an array of 8 inventory items, 2 for the equipment, which is left hand and right hand again. And if we look at the description, what is an item, it actually has an ID, so every item in the game has a unique identifier. Then there is a flag whether it's movable or it's not movable. Everything in your inventory is movable, obviously, because you could put it in your inventory. Now, for example, a signpost in the game or a door, these are not movable. Then the graphics ID is a string. It basically says which texture or which sprite to use to render this item. And then there's the name of the item. The name of the item is if you hover over it, like this empty flask, this is the name of the item. Yeah, this is how it looks. Then there are other packets which we will probably get into later on, like mobile information. Mobs are basically every player, every creature in the game is a mob. There are not too many mobs in the game, there are only players basically. So yeah, this is a player, for example. The name change actually did work for the person. And every player is either a male or a female dwarf wizard. So that was also a funny design decision. Now let's go to the forest, because I like the forest. The graphic artist really did a great job with the forest. In what games do you have unlimited inventory? So usually, like for example, I played Ultima Online, and there you had a system of a backpack where you can place any item anywhere in the backpack, I mean with 1 pixel precision, right? And one item could be on the top of the other one, and basically the only thing limiting you is like, can you find something in your backpack if you threw the stuff around, because you could have like 10 items on the same position, and then you'd have to just drag them to see what's under them. You couldn't move if you were overweight, but you could like teleport around, for example, or yeah. So that's basically one of the examples I can think of. There might be some other games, like usually single player games, you do not really have limited inventory. Yeah, play an animation. This is something the server sends to the client, and it's same like text, but in this case it's an animation, and actually it's not implemented, so we can ignore it. Then there is ground information. This is information about what is on the ground. The server sends, like watching at the map, right? So the server knows the player is here, and then the server gathers all the item surrounding the player and sends information where the item should be located, should be displayed in the world. There is, this is not done efficiently on the server currently, but it's how it basically goes. And it sends a list of items per tile. Then if you hold something, so as a client want to hold this, so I press my mouse button and I start holding it, but you can see that I'm clicking now, and there's a slight lag, half a second lag before the flask actually jumps to the middle of my mouse pointer. And this is because the client sends a request, I want to hold this item, but the server has to check whether the item is actually, can you hold this item? Maybe it's not movable, maybe you cannot reach it because it's on the other side of a river or it's too far. So the server decides that, yeah, you can actually hold it, and then it's holding. And what this actually does, because this is quite funny, the rendering, like that flask disappears from the world when I'm holding it, and it's again in the like inventory space, in the secret inventory space of a player now, and it's not really being rendered by the same code which renders the items. Is being rendered by like an abstraction layer for the mouse cursor. So the flask here is a mouse cursor. And if you watched or play with a web client, then you will notice that the flask, if you hold it, would be small, would be the size of your normal mouse pointer. That's because I didn't implement scaling of mouse pointers in the web client. If you use an item, for example, this packet is sent from the client, and so on and so forth. So I basically started with a list of some packets, and then as I went, I needed to add another couple and remove a couple, but everything like that is basically in this README file, so check it out. Now, another important file, the most important file probably, is the credits file. All the graphics that you see in the game falls into three categories. The first category is like the trees here, or the UI, or the actually, you know, the characters were made by Bertrand, and I actually own the copyright to that art. Please assume they are CC by SA 3.0. By I do mean you have to say that it's done by this person. Yeah, so this was a hired graphic artist. Oh, hello there. There's someone hiding in the bushes. Anyway, so that was a hired graphic artist. I really like his style. This is like the second time I worked with him, and he's just amazing. Yeah, there were some graphics which I made. Please consider their public domain, basically, because yeah, I mean, like, for example, icons here are like something I made. So, or like this magical arrow. Yeah, I'm sorry. I totally don't have any talent. Now, everything else, for example, the items, or the texture of this road, or the texture of the grass, these are things from the opengameart.org. So if you go to this site, if you're making games or like making, I don't know, you need some graphic art for some reason, then do check out this website. It's actually pretty amazing, and they have a lot of free content usually on common creative license or public domain licenses to use. So the rest of the file actually contains all the art which at some point was in the game, including links and including which license is specified next to it. So yeah, for example, all the items are from some item pack. Where's an item pack here? I'm pretty sure it's somewhere here. Anyway, so that's that. Then, yeah, and then we have to get to the code now. I'm going to check if there are any questions. Yeah, so the question from Adorba Supervisor is, this is on top of TCP. Yes, this is on top of TCP. I decided to go for TCP and not UDP. Usually in games you go with UDP, but TCP makes a lot of sense in this case. because I have a session established, and we'll get to sessions in a second. Did the players have this documentation? Let's check. It actually should be in the backup file and this file if they had it. And no, they didn't have this documentation. So they didn't have anything which is written here. The documentation is not complete, by the way, so do take that in mind, or it might be outdated because I sometimes jumped to update it and sometimes I didn't. The network protocol is fully updated. This is the state which is in the game because I needed it to be updated, because otherwise I would just, you know, get lost. Yeah. Okay. There are 2 other questions, but I'm going to answer any question which is not related to the topic at the end of the live stream. Sorry. So I guess we can discuss one more thing. What I wanted to do with the game is basically I wanted it to be playable as a Windows application or Linux application, but doesn't actually matter. It works in both on Linux and Windows. But yeah, it had to work on Windows and Linux. And so that's one thing, right? So there's like Windows, Linux, there's the normal client, but there's also the web client. I wanted the game to be playable with a web client because I wanted there to be the first task, which I described, of basically hacking the console, or actually getting the backup to be able to get the proper client of the game and play the game in a more hackish way, in a more hacking way, right? Now, to do that, I could do 2 things. I could do the way of OnLive, for example. The idea behind OnLive was that they basically run a normal game on their server, and then they somehow intercept the input and output from the game, and and then they stream that to the web browser. So this goes to dub. Yeah. Thanks for the stream. Support your local hacker. Thanks, Devno. Thank you. Yeah. So basically, that's one way to do it, and I didn't want to go this way. I specifically didn't want to play with proxying, like catching any DirectX calls or OpenGL calls and then getting the frame buffer and proxying it. No way. I didn't want to do anything like that because that's seriously complicated. What I wanted to do in the end is I wanted to have the game client be able to have, like, the engine would be totally agnostic of where it's rendering to. What the engine would do is it would give you a bitmap. So the engine would always gives you a frame, a bitmap. Yeah. And then I wanted something to render the bitmap. For example, it could be, you know, like a website. In the end, right? It might be a website. Or it might be a native client, so like SDL2. So there would be this thing, and this thing, like the web, either the web client or the SDL client would also get the input from the player, which would be mouse movement and keyboard presses. So they would have the I/O, and they would send it back to the engine, and engine would process the events, like the movement of the mouse or pressing of the keys on the keyboard, actually like pressing and then depressing, which is actually like releasing the key, and yeah, everything would be done here, and these would only get the bitmap. So the bitmap would be sent to this, or bitmap would be sent to this. So the engine would have to fully operate on basically on arrays of bytes. All the graphics which you see is rendered into an array of bytes. And that array of bytes is then being sent to SDL, for example, to being displayed, or to the web client to be displayed. And this means I had to basically separate this part and this part from the engine. So the engine had to be a separate entity. And this was basically how I sort of designed the game. Now there was another part of this because I also needed the engine to be able to chat with the server, right? The game server. So there was a network part, which was a different thread, a different entity, and the engine would also chat with the network part, would tell it, hey, I want to send this packet, and also process all the packets which the network part would actually receive from the server. It would pass it to the client. So yeah, this is basically the design of the client which I went for. There are three parts again. There is the agnostic game engine, there is the network part which communicates with the server, and there is the web client part and the SDL part. I guess I'm going to start with actually discussing today the web part, the thin client, how that was done. But do keep in mind that basically the web part only got a frame, a bitmap of the frame, and sent back the input to the engine, and we'll discuss the engine either next times or somewhere in the future. Did I move? Anyway. So, I guess we can go to the client first. I apologize for the quality of my code. Do keep in mind, everything here was written either late evenings or like at night, basically at a really, really heavy crunch time. So the code isn't beautiful. You have been warned. I'm sorry. Okay, so let's look at the... I'm going to discuss only, I guess, the first part. And yeah, UI common, basically, this is the thing. This UI common class defines how... so this is basically... if you wanted to, hook the SDL2, or you want to hook something else, like, I don't know, WinAPI, or you want to hook OpenGL for displaying this, what you need is to implement this class UI. So there are, like, for example, WebSocket implementation for the web client, and there is also SDL2 implementation later on. And it doesn't have too much stuff. It basically has, like, this initialize thing. It has a process events thing. So basically, if the game server is sending a new frame, so the game engine is sending a new frame to the client to be displayed, then it would be processed in this processed event function. And then there's a join. A join is like like basically wait for the thread and finish. And there's also another function, like it's a helper function. Is it okay to sleep or is it not okay to sleep? To basically decrease CPU usage. For SDL, it was always, the answer was, it's not okay to sleep. I want the game to be with maximum frame rate with WebSockets because we expected that the server will be rather slow and unresponsive. I think the answer was, it depends. Like, if there are no events from the client, from the, the real client sitting in front of a web browser, then it would sometimes say, yeah, it's okay, you can sleep for like 5 milliseconds to make the CPU usage lower. Yeah, so there's that. Then if we look at an actual implementation, let's start with SDL2 because that's actually easier. It would obviously have some other typical SDL stuff, like, for example, a window, a surface, and so on. A surface is basically a frame buffer, or more like a canvas thing. And also, like, stuff related to the mouse position. This is the current mouse position, and the cursor hot point. So if you have a mouse pointer, right? Let's say this is a mouse pointer. I apologize for my drawing. Then if you move it around, right, like I move my cursor around, if you click something, you actually need to tell the system, the operating system, or like the game engine or whatever, where is the place you clicked? Is it here? Or maybe is it here? And it's quite obvious for the mouse pointer. It's probably going to be the left upper like coordinate, like 0, 0, right? But if you then have a crosshair if you have something like this, then the hot point would actually be here, right? So yeah, so this is what was the hot point is for, to basically also know where to render the cursor, to render it in such a way that the coordinates are exactly in the hotspot, in the hot point of a cursor. Then I have some function to convert a mouse pointer, because you know there's the window coordinate, like this is the window coordinate, right? But if I do like this, for example, then the window coordinate is totally different than the game coordinates, because the game resolution, and I wanted it to look old school, is 240 in height and 428 in width. So it's a panoramic old school resolution, basically. So yeah, so you had to basically, if I have my cursor here and my on screen, here, then on screen my window is actually like, I don't know, like 1000 pixels, then I need to scale it down to the 428 resolution. So this is what the function would do. I'm reading a question. So the question is from the robust supervisor: would it have saved a lot of time to make the C++ API available through FFI, Python WebAssembly? I'm not really sure what FFI is. So it takes your inputs and gives you a BMP. That way you could have done the render in JS or Python. I could have, but I didn't want to, because I was pretty sure I'm going to have to do the software rendering by hand, and I value the speed of C++ rendering, unless you mean just the rendering of the bitmap or whatever. Then I didn't think about it, basically. I basically just hooked up SDL2 for rendering initially. Well, initially I dumped it to a file, and yeah, and then I hooked up SDL2. That's actually how it was. Now, okay, so let's look what process events does in this case. Oh, by the way, the second implementation, the web implementation, is actually WebSockets. So WebSockets, as you might know, is one of the ways to communicate real-time without using the HTTP protocol through, between a web browser and the server side. Because HTTP is like this: you send a request, the browser sends a reply, and then the connection is killed. Well, the connection doesn't have to be killed, but all in all, it's a pretty slow for like real-time application, real-time data exchange in both directions. Because, for example, normally in HTTP, the server cannot initiate a connection and send you, like, push you some data, right? But using WebSockets, you can do just that. So this is basically a super similar thing to what is in the SDL, but it's actually an implementation of a WebSocket. So what it really does, it translates events from the client, from the game engine, and it pushes them through the WebSocket to be displayed in the web browser, and we are going to look at that in a second. Cool. So okay, this is the header. Let's look at the actual implementation for the SDL initially. This is the process game event. I guess it's most important, because in the init, what's in the init? In the init is only, yeah, like initialize is typical SDL initialization and creating the window, you know, so the window is created, and then you get the surface so you can actually draw on the window, and that's about it. One important thing here is that the parts of the game, the three parts of the game, chat with each other. They are run in separate threads, and there might be actually multiple threads as well. So they chat with each other, communicate with each other using a game queue, a queue basically of events, which is a standard way to do it. So there is a push function which pushes an event to another part of a system, and there's a receive event basically, which does the opposite, right? We can look at the implementation later on, but that's basically it. Now the process, yeah, so that's on the initialization. Now, if we look at processing the events, this is, I think I was in the proper place, yeah. Then, yeah, it basically calls, like, we process SDL events, then the game events. So SDL events is basically, you know, like input. keyboard input, mouse input, maybe the window change the size. That's also an SDL event. Then there are game events, which is the server sends us a frame, or the server says, please change the mouse cursor to something else. Eventually, sounds would be here as well. The server, the game engine, tells us to play this sound, but sounds are currently not implemented. There's some infrastructure for that, but it's not implemented in the end. Yeah, so the SDL events might be like this. Basically, we get an event and we get, for example, Windows got resized. So it just handles it, basically. Then we have like a key was pressed, and this is more interesting, right? Because this is the input which the game engine cares about. So what happens here is that we basically get some SDL key code and we convert it to a engine code, because the engine had to have their own code defined basically to be able to process them, and they had to be like agnostic to like Win API key codes, or agnostic to the SDL key codes, or whatever key codes are going to be used in JavaScript. So yeah, there had to be internal codes for the keys, and the internal codes for the keys were rather easy, I would say. Yeah. Here we go. So basically, like, yeah, it's like, you know, one-to-one mapping almost. And then for special keys, I had a little more weirder mappings, like using this range. It doesn't really matter. But yeah, some of them were ASCII mappings and others weren't. And then if the code conversion was correct, because for example, if you pressed, I don't know, like F14 on your keyboard, I didn't care, like the engine didn't care about it. So the engine would be like, this conversion function would be like, yeah, I totally don't care about that, that's a 0, and or like a -1. So yeah, the engine basically code only about key codes which were above 0. For example, like 41 would be A, right? Hexadecimal 41. And then it would create an event, like event UI game, of the type, depending on whether it's a key down or key up, it would be, well, key up or key down, but again with an event name which is related to the engine and not to SDL2, for example, and the code, and this would get pushed to the queue. So this is how the translation was done between the input library and like input-output library and the actual game engine. And if we look at the code for WebSockets, it was like super similar. So here's WebSocket. So okay, I see a comment on the chat about this. Yeah, because I wanted all of them to be run at least once, but I still wanted it to be returned. Now, there's a funny thing which I did already tell about, is that this actually makes a conversion to an integer, then to a bitwise end, and then convert it back to Boolean value, which is kind of weird. But yeah, it's still fine. If any of these would return false, then the game would quit, basically. So that's why I need to keep track of it. Now, if we go to WebSockets, let's look at the same stuff related to the keyboard from the website. So assume that there's a website, and if you press a key, then JavaScript sends a WebSocket packet to this code. And this code basically has a socket open, and it receives, there is the receive function somewhere here, and it gets a WebSocket event, and then the event is being processed. So this is standard WebSocket code, because I implemented WebSockets because yeah, that's actually me, right? Instead of using a library, I just implemented it. It's not a hardcore protocol by any means, and it's, yeah, the best thing to do at 1 AM is to implement WebSocket. Okay, so then these are the game events. I don't want to talk about them yet. I want to talk about this. Okay, so we get an event and then we have to actually process it. Okay, we get the payload, blah blah blah. Where is processing of a payload? Process view is right here. Okay, now this is the frame, and then because WebSocket is actually like a two-layer protocol, on the first layer there are packets, but the packets form bigger packets basically. So you can have one big packet, like high-level packet, being split into several small packets and sent like that. So in the end, in the end we get here. Okay, and we were looking at key down. Okay, so this is key processing. This is key down, this is key up, I think. And we basically check if, if this is down, then we get some frame data. As you can see, this parsing here is really crude. And I didn't show you a protocol definition for the packets being sent, the binary packets being sent from the WebSocket. And the reason for that is that I didn't really write down the definitions of this protocol, because this protocol has like 3 events which are like 2 values or something. So all the parsing is done basically like this. This is basically like getting together a 16-bit value. And so it gets the code. Now the code, since I written the JavaScript code did convert the JavaScript key code to the game engine key code. So here the code is actually already the converted game engine code. And I just have to cast it, and that's it. And this is the same, pushing the event to the game engine, where the game engine would process it, but we are not going to look at the game engine today, I guess. So yeah, this is how it looks like from receiving an input and then passing it to the game engine. Now, what happens when the game engine actually sends a frame to us? In the case of WebSocket, this would be, where is the code for that? Yeah, process game events, that would be it. This is some, frame limiter. Yeah, I didn't want to, this is a software engine, and in all honesty, it's somewhat slow. I didn't do my best job for it. I could have done a way better job. I guess I get like 120 FPS on my machine, but if you have like 10 players playing through the web on a server, that would be really slow. So I limited it to, I think, like 10 frames per second, and this is the code which does that. And then we actually process the game events. For example, if the frame is ready, then we, this is quite funny actually. Then the frame diff is being sent. So this code basically remembers this is the last game frame I sent. Like for example, it looks like this. And then the engine renders a new one, and sending a whole frame like this without any compression is like 300 kilobytes. That's not a lot, but not a small amount. Like it's not a negligible amount either. Therefore, there is code here, like in this send frame diff, which takes the old frame, takes the new frame, and starts going line by line through them and sees which line differ. And it sends only the lines which are different, and it doesn't send the lines which are not different. So for example here, now if this would be a web client, right, nothing would be sent because there is no change. And for example, if I move my mouse to here and the empty flask text appears, then only these scan lines, like from this range, would be sent because only these were updated. Well, actually only these related to the text itself. And this would not be sent, and this would not be sent either. Apart from keyframes. Keyframes are the frames where the whole frame is sent regardless of everything else, and I think every 2 seconds a keyframe is being sent just to make sure there is no desynchronization, like some packets didn't get lost. That shouldn't ever happen in the way this is designed, but just in case. Like for example, I don't know, the WebSocket connection broke or something, but yeah, it should be fine. So anyway, I still send keyframes every now and then just to make sure that the whole frame is being refreshed. Yeah, then there is another thing, like for example, if the cursor, the mouse cursor changes, in that case the game engine also sends like a bitmap, like a small bitmap and a hotspot, right? So the bitmap is actually being, like the size of the bitmap and the hotspot are being packed into 16-bit, well, the 16 bits are being split into bytes. This is this code, and then the frame itself, the data, the bitmap data for the cursor is also being added to the packet, and that's also being sent through the WebSocket to the JavaScript, right? So this is how it looks like from the game perspective for the web client. Now, what happens to this WebSocket, and why do we have a WebSocket in the first place? To talk about that, we do have to move to another directory, and the directory is called the thin client. Rewrite the game in Rust. I don't know Rust, so that would not work. Okay, thin client. Yeah, so if we move into the thin client, then there is not a lot of code, in all honesty. There is the main Python, the network helper is, there's almost nothing here. There's like receive until you get this text, or like receive all of these bytes. These are, I think, the only functions here. So, and then there's the static, and the static are actually the HTML and the JavaScript, and we'll get to this in a second. And there are some images as well. I can show you the images. So the images are like, so okay, let me maybe show you the website. Will this work? Wait, why does, oh, because it's packed. No, it doesn't work. I actually need to spawn the client, so spawn the server. To spawn the server, I need to run it on Linux. So let's do just that. Okay. Run sh. What is run sh? Okay, run sh is fine. So. Okay, and now I can like. Oh, I've been shoved by a wall of force. Somebody found the spell to shove, to push me. That's funny. Yeah, so this is the website, and it doesn't interact with the client, the thing I described yet with anything. You actually have to type something here and then click connect for it to start doing something. Okay, but let's look at the code. So the code is like this. It's basically an HTTP server and the proxy for a WebSocket. But I did show you the WebSocket implementation in C++, so how does that work, right? Why does this, yeah, like, what's up with this? If you know how WebSockets work, it's like this. The client, the browser, sends a HTTP packet, basically a normal HTTP packet, to the server, and it says, I want to upgrade this specific connection to be a WebSocket. And then the server checks a couple of things, and the server replies that, yeah, sure, like WebSocket, totally, let's switch to WebSocket. And from that moment on, the connection switched to WebSocket. And the design of this HTTP server here is that as soon as we switch to the WebSocket protocol, then it actually spawns a new process. It spawns the client. So, sorry, let's maybe do it like this. It creates the calls client, and it passes to the client which file descriptor to use for the network connection. So the client doesn't listen for the network connection. It already gets a socket which is configured in a state where the WebSocket is being used. So that means that the client has to have the WebSocket implementation, but it doesn't have to have the HTTP implementation, because the HTTP implementation is in the Python thin client code. Now, actually, yes, I also implemented HTTP on my own, and that actually yeah, like my teammates were kind of laughing at me about it, that like, why did I implement HTTP? But in all honesty, HTTP is only like I don't know, like 40 lines of code, so whatever. I seriously didn't care about it. It was faster than looking up how to use a library for HTTP. I know that Python has a built-in simple HTTP library, but still, I just decided, because I'm doing this weird thing when I'm creating a new process, and the new process actually will inherit a socket from me and do stuff with that. I do not want to use any code doing anything on the sockets which I do not control and do not understand in full, because that might backfire seriously bad. And this code was written around, again, like I think like 6 p.m.-ish in the last day just before the CTF. So yeah, I didn't, I couldn't afford to risk. Yeah, so this is the HTTP server. Basically, there are two handlers. If the path is WebSocket, then it goes to handle WebSocket, otherwise it handles HTTP. And if anything goes bad, it sounds like this, like something went wrong, right? So, yeah, if we do WebSocket, it would actually go to a different handler. Now, this is the WebSocket handler, but let's talk about it in a second. I wanted to show you the HTTP handler. Yeah. So basically the HTTP handler is trivial. It removes all the funny stuff, or actually throws an exception in case there's any funny stuff in the path, requested path. If it's indexed HTML, then the path is actually the same as nothing. And otherwise, it tries to open a file in a static directory. So there should be no path traversal here, it should be fine. And it opens the file from that directory. Then, depending on what is the known extension, it actually selects the proper MIME type. And then it sends like the, well, it sends basically the red file, because the file is red, from the directory, and also the header, right? The typical HTTP header. So yeah, I mean, HTTP server is easy, right? This kind of HTTP server, not like a general purpose one. That's a totally different story. Yeah, and at the end of the day, by the way, this is just a standard listening socket, which creates a new thread for each connection. So new connection, new thread, which gets the socket and processes it. Otherwise, if it was actually a request towards the WebSocket path, right, it goes into this. And what this does, it basically initializes the WebSocket, but it also initializes the environment for the client. So for the client, it has to set several environment variables. It has to set like fd, which is basically the file number of the number of a file descriptor for the WebSocket to use. It doesn't have to do any other magic to pass the socket to another process, because it is a child process, and by default all file descriptors are being passed to the child process, so the child process can actually use the file descriptor of the parent's network communication without any problem. So it just has to know which one to use, and this is why I'm passing this number here. Well, then the password which the user provided, it goes actually through a cookie. Same with the name. The cookie probably isn't the best storage for this kind of stuff, but again, this is a CTF challenge, so I didn't care about it too much. And also the UI type has to be selected for WebSocket, so the client actually uses WebSocket and not, like, for example, SDL2, which is another proper value, and also the default value. And then it's being run using popen, and yeah, and is running. And then if it communicates, actually what it does, it waits until the process finishes and gets any output, and the output is outputted for debugging purposes to the console of the thin client server. So this is basically how it works. I guess I can span it locally. I did span it locally, and I can try to log in as a player like this, and ASDF. And it says it failed to run the client. Yeah, find values. Values is, you know, Arcane Sector team captain and also our main admin for the CTF. So yeah, Just a little hint what to do on a CTF if this actually fails. I don't think I have the client compiled for my operating system, my Linux, which runs here. I think it's compiled for a different thing. So I guess we will not be able to test it here, but that's not really a problem because it would just show us this frame, right? Now everything else is actually in JavaScript, so let's look at that as well. Yeah, and yeah, all the JavaScript, I'm using jQuery here, which is quite important. I'm also using a JS cookie library for cookies, but everything else is in one file. Again, I was writing it a day before the CTF, when I was already at the conference preparing everything, like it was Sunday or something. And so, yeah, there was no time for clean code. It was just everything goes into one file. I don't care about style, like it just has to work. And it did. Cool. So, basically, well, there's some fancy animation, like if you refresh the page, there is the sliding effect, right? And then there is this map background scrolling in the background. The map is also, and this, like the graphic is prepared by Brehm. So yeah, he did a really good job. Now the map you might recognize actually from our CTF, and also the game takes place on one part of this map, but just a random idea. Sorry, random thing about the game. Now. How does the WebSocket processing goes? Or let's look at it from a different perspective. If I press a key in the game, right? I press a key here, what happens? And to learn that, we need to find the key handler. And yeah, there are like window, key up, key down, events registered, and it's send key event function that we need to look at. And the function is like this. Basically, if there is no WebSocket connected, then whatever, just exit. Then it needs to convert the JavaScript key code into, again, the game engine key code, because as I said, it's being done in the game engine, and this is actually, yeah, this is like just a dictionary, right? So it looks up in the dictionary, for example, this free, and it converts it to this code, and this is the code which is going to be sent. And after it has it converted, it creates a packet using, well, again, the brutal method of creating a packet. The network layer between the game server and the game client is actually way better than this, right? But again, the protocol for the WebSocket communication, you know, the high-level protocol, the application-level protocol was actually super easy and super short. There were only a couple of packets, so I could afford to do it like that. Yeah, and that's basically it, right? It says whether it's down or up, then it gets the bottom byte of the code, the upper byte of the code, and it sends it through the WebSocket. This is, by the way, a standard JavaScript API for WebSockets, so you do not have to implement WebSockets yourself. It's already there, and that's it. There's nothing else. Identical code is there for, you know, for a mouse, like for a mouse event. So if you moved your mouse, for example, then this would get called, and it would do the mouse calculations from, you know, the browser window to what's the coordinate actually in the in-game, and put everything in a packet and send it, and prevent the default. So the default thing on the browser doesn't happen because, well, the event is actually processed on the server side in this case. Mouse up, mouse down, the same thing. Now, what happens if this code actually gets a new frame from the server? So yeah, there's some JavaScript animations here, and there is this game connect. So this connects to the WebSocket, and on message is the handler for the messages. If a new message, a new packet arrives from the, like a high-level packet through the WebSocket from the game client to the browser, it basically does this. There's a funny thing I actually did. because I didn't want to copy the frame around in memory in the client to match, I actually abused the so okay, it's like this. The format of the WebSocket, of my protocol in the WebSocket is like this. There is the packet ID, like the chunk ID, right, which is 1 byte here, and then there is the structure. And if I wanted to say send a frame or a keyframe, then what I needed to do is I needed to basically take the keyframe, the frame which I have already ready, and I can do whatever with it, then create a new buffer, allocate a new buffer, write this at the beginning, and then copy this, the whole frame here. And I didn't want to do it, so what I did is actually, if the chunk ID is even, is like divided by 2 is equal to 0, so you know, that's not divided by 2, but modulo 2 is equal to 0, so it's an even number, then it means it's a keyframe, which also means that I do not really have to do all this dancing around with a buffer. I can just clear the low bit on the first byte of the keyframe data. So if you would compare the first byte here with between the rendering in the client, the SDL client, and the rendering in the WebSocket, you would find out that there is 1 bit difference on the red color because of this. And it's a stupid hack, but I decided to just go for it. Yeah, so if this is detected, if that bit is 0, then I know that I have to either get a keyframe and just, you know, get image data from it, and then output it using Canvas, because in the web client, this isn't Canvas, but, no, I actually like, this isn't Canvas, but everything else you see is the canvas which the game is being rendered on, so I just have to basically show it on the screen using the standard JavaScript canvas stuff. And yeah, and then I have to act the frame. Now, I actually, and this is only for keyframes, for diff frames, for where I'm only sending the scan lines which are different, then I'm just doing, you know, normal packet IDs. And all the packet IDs, please notice that all the other packet IDs are always odd. They are like never multiples of 2. So this is 1, for example, this is 21 for the cursor, and 20 so for cursor disable, and 23 for cursor enable, like custom cursor enable. Yeah, so that's basically it. This is basically all the code that the players got at the beginning, is this JavaScript. Yeah, so yeah, this is basically the thin client and how it works and how it connected to the client. And that's not for today, that's for the next time, is actually how to how the client renders things, how does it draw things, because again I mentioned that this is actually a software engine, and how the client connects to the server, and then how the server does the world and event processing. And I will move to that basically next week on the next live stream, right? So this is where I'm going to end it today. Let's just move. If you have any questions about it, then just yeah, let me know. You can let me know now actually, and I will answer it if you're watching this live, of course. Apart from that, obviously feel free to download the code and experiment on it. I didn't decide on the license yet for the code, but it's probably going to be GPL. So I just need to upload the files and, like, you know, fix the headers and so on. I see you're learning Polish on the chat. Matrix says that it isn't hard. Repeat after me, KrzaQ. Yeah, that's how you pronounce it. It's KrzaQ. Okay, let's go with the questions. Here we go. The questions, you will see them here. And the question is, have you tried making some Android custom ROMs? I didn't try to make them. I tried to use what was it called? I don't remember. There was one. and I tried to use it on my one of my previous phones, which I rooted. It was working mostly fine, but then got some issues, and in the end I decided not to play with it too much. But apart from that, no, I actually do not know too much about Android. So yeah, it's just, you know, not my thing. Have you tried out the Hack the Box EU CTF challenges, and what did you think of them? So I didn't. I think we have some scheduled, but I as in Foxtrot actually got some permissions to for us to hack some boxes from that collection, but or maybe that wasn't Hack the Box. No. That was a different thing. I'm thinking about full boxes. Anyway, so no, I didn't look at the Hack the Box CTF in that case. Sorry. Oh, it was the same thing? Okay. The Supervisor says that the Android mod I was thinking about was Cyanogen mod. Yeah, that was it. During C++ versus security linked C++ core guidelines document, can you recommend something similar for C? Not really, actually. If you look for, I think either US CERT or SANS have a document about secure coding in C. So look for secure coding in C, like that exact phrase, and there should be some document, but it's not the same kind of as the C++ core guidelines, which is pretty cool. Learn Rust. Yeah, it's on my list. Learn C++. Yeah, I have to someday. I'm pretty sure I asked like KrzaQ several times during the coding of the game, like how to do something. Listen 1, 2, 3. Are you sure it handles to? So okay, so this is actually a good question. So what listen 1, 2, 3 means, it doesn't mean I want to have at most 123 connections. I want to have at most 123 awaiting connections that need to be accepted and processed. So that means that if more than 123 players connect at the same time, and I don't, my code isn't processing the connections, accepting the connections fast enough, then any other connections attempt will drop. But if they try again, then they will successfully connect, and then that will be fine. So yeah, that's 123 is about not all the connections you want, but about the queue of the connections you want to have waiting for you for acceptance only. Like, because, you know, there's listen, accept, right? Have you done anything useful with the Xeon Phi from the Polish live stream? No, because I still don't have a motherboard which supports it. So yeah. So no, it's still on my list. I still need to figure out how to probably do that. And the other thing is that I actually need to figure out how to do proper cooling for it, because passive cooling, as I learned, doesn't mean you do not need to cool it. It means it awaits external cooling to be applied to it. The more you know. Yeah. Why GPL? Again, I'm still thinking on the license. Probably GPL. If you want another license, then let me know. What are you thinking about the Supervisor? Because I was also thinking about like maybe go with some BSD style or MIT style or Apache license. So I still need to figure it out. But if you have any good arguments, or you have like, you think you want to do this thing with the game, then let me know. I might actually go with a different license. Yeah, Foxtrot Charlie asks me, how did I learn Polish? Because my pronunciation of KrzaQ is amazing. It's a long-running joke. But sometimes I get this question on Polish conferences, because, you know, folks don't always realize that Genveil Coldent is not my real name. It's not, by the way. So, yeah, and they expect somebody speaking English, for example, and then I come and I speak Polish, and my Polish is actually pretty okay. well, I'm a native, right? So yeah, and when I get like they approach me and they say, like, sir, you're Polish. It's really amazing. How did you learn it? And that's like, yeah, that's hilarious. Okay, so that's it for today. Yeah, about MIT and BSD and GPL, I do know the discussion. I'm just still thinking what exactly I want to do with this game in the future. So, yeah, perfect. Let's see each other on next week if you're still interested about how the game works. Otherwise, have fun with the code, which is on GitHub now. And today's moderator was Foxtrot Charlie, so thank you, Foxtrot, for being here. And that's it. I'm going to leave you with some music, and yeah. And do remember to check out DevNull's YouTube channel. It's really cool as well. Perfect. Yeah. So, some music, and see you next week. Bye-bye.